The target user is very different from people who work on voice AI day and night.
Right.
The way you interacted with the system right now, on the one hand, looks like a great interaction because you were so assertive.
Correct.
But I think the issue is you were that assertive. And I think
because I know how it works.
Hello, everyone. Welcome to another episode of Deep Learning with PolyAI. I'm here with my co-founder, Shawn, in another quick take reaction video to the release of OpenAI's Realtime API.
Yeah.
So I think to everyone who's used the ChatGPT app, especially its voice mode, it was clear that it got way better I'd say about 2 months ago.
Correct.
It just got to a point where we're just like, wow, right? Like the reactiveness, the ability to hold the conversation, the interruptibility was like spot on, perfect.
Yeah. There was this woman voice,
the
British.
Phenomenal.
Yeah.
Yeah.
That was really good.
Yeah.
I can't remember on top of my head right now. And I remember when I went to GTC in Paris and I talked to some of the OpenAI guys, and it was just like, oh, we secretly shipped something, real time with voice mode, a couple of days ago. And then everyone here, it was like, oh, that's super amazing. And then, afterwards, I just realized they were talking about that secret release of ChatGPT.
I love a good like stealth release, but
and then afterwards, when we found that British female voice, we tried to go onto the API documentation, try to find where she is. Guess what? Not available.
If only you knew her name, maybe you could access it. Secrecy, but
we do know the name, but now I've because it's not available.
But I think what was interesting is that when you tried to use the API, it clearly wasn't the same. Right, it wasn't the same release, and like I think Friday, Thursday, last week we got this like GA release, the voice mode, of the real-time API, where I think we finally got like developer hands-on access to this like real-time API.
Yeah,
and like I think in this video I'd love to kind of like cover what it means for the industry, but also just like first off, maybe what it is. So I think it'd be great if you kind of like maybe explain to people like what is it really? Because I think everyone's now pretending that it's a game changer and stuff, but maybe we'll just start from the basics. So like what is this thing? I'll share our Miro board.
So if you think about traditional voice agents, people usually implement it in a cascaded pipeline, and this is still the mainstream architecture right now, as you can see on the left-hand side, that you basically have three kind of machine learning models cascaded together. And then these days, the people like to call it like speech cascaded pipeline. Usually comes with these three different modules. And the reason that you do that is because historically, voice-to-voice data is very hard to collect. And to be honest, these days, it's still very hard to collect.
Compared to text data, right?
Yeah,
you're crawling the internet.
That's right. And if you train a large language model, then you can train these speech recognition and speech to text to speech models separately. Then you can, and because like these models require different data collection procedures, different framework. For example, speech recognition is very important that you collect a lot of different people's voices and over different noisy conditions and different accents, so that your model can maximize the likelihood of recognizing the speaker. However, the text-to-speech model, what you wanted to train on, is generally high-quality voice actor data, because you want your voice agent to sound like professional, crisp, and very nice voices. So the different way, these like different requirements, kind of like detect that the way that you're collecting the data is very different.
Yeah. I mean, to kind of like maybe use a different, simpler analogy, like, if we were in the gym, these are isolation movements, right? Where you're training your biceps and your legs and your core muscles differently.
Yeah.
Then you hope that it kind of like comes together well. Whereas, if you're doing just like squats, pull-ups, and deadlifts, a lot of people say you're doing, you're training for strength, not for looks, and that you get it a lot faster.
Correct.
But the promise of if you can get it right is that it learns to pick up all sorts of things that matter for the composite task, right? And again, collecting data here is hard, and I think they don't really reveal the full details of how they or anyone else does it.
Yeah.
I think, I remember your end-to-end paper back in, I think this was 2015.
Yeah.
Right, and that was like end-to-end training, very specifically, not in the end an end-to-end model, but like the hope was that all three components would get better because you're training them on the composite task.
Yeah. I think, based on these like real-time APIs, they, people, because it got released like last October, and then since then it has gone through several iterations as well. It's quite clear that the benefit of it is that is basically you remove the boundary between three models, and then you will be able to unlock new exciting features like hey, speak to me with strong French accent, for example, or like become very emotional aware, like be able to laugh, be able to actually cry, etc. These kind of features is not something that cascaded model can give you, because the text doesn't have a very strong representation of these emotion text. So these are like very cool feature you can unlock with a speech-to-speech model. Another benefit is that it reduces the latency overall, because then you don't have to wait for one model to get it down to the other one and things like that. So it has these.
And I guess with that, maybe a third one would be just like we say barge in and interruptibility, and we'll show how it works. But I guess the real thing is this like melting of the turn-taking paradigm, where now, when you interrupt, let's say that I'm a system and I've said 5 words and you interrupt me, it doesn't mean that I just stop speaking. It means that the model is aware of what it said in those 5 words. And then it's aware maybe it gave you a key piece of information that you would have heard versus it didn't give you anything, right?
Correct. So I think, one major difference is exactly that turn-taking functionality. Because historically, we are treating turns as boundaries of the interactions. Now, agent can interrupt you anytime. You can interrupt agents anytime, because the conversation is now on one single stream of events. Events happening from the agent side, it happens on the user side, and it's detecting them together. But eventually, you need a mutual protocol, how to interpret those.
Totally. It's almost like, one version was like we're playing tennis and passing the ball back and forth.
Correct.
The other one is we've got a machine gun each and we're shooting at each other and, we see where we end up. Very Serbian analogy. Sure. Okay. Well, maybe like to kind of like go into just like the performance, right? Like, do you want to like show
Sounds
it? So I think we have it integrated in the platform already.
So let me just like quickly show the demo that we built last Friday once the agent come along, and we just integrate it to our platform, and then now you can actually talk to it with our systems. All right.
Hi, thanks for calling PolyAI Private Bank. How can I help?
Hi, what can you do for me?
I can help with checking your account balance.
Can you just set up a payment for me?
Of course, I'd be happy to help with that. For security,
so my name is Shawn Wen. The phone number is 07715000999. Date of birth is 1988, November the 2nd.
Thank you. That matches our records for Shawn Wen. You're now verified. Let's move on to setting up your payment.
Can you set a payment to Nikola Mrkšić, and can you just send him a 50 pounds immediately, right now?
Understood. We have the payee name as Nikola Mrkšić, and the amount is 80 pounds.
MRKSSC.
No problem. Could you please say the full 8-digit account number for the payee, so I can make sure everything is correct?
It's 00112233, and the last name is Mrkšić, Mrkšić.
Thank you for that. Let's confirm the details. Payee name, Nikola Mrkšić. Payee account number, 00112233. Amount, 80 pounds. When? Immediately.
Correct,
One moment while I set that up for you.
Thank you. Can you let me know when it is done? Hello.
We'll get there eventually. So I think this is really interesting, right? I mean, we'll talk about like tool calling and stuff, and I think accidentally worked a second ago or we tried, but like what I think is really interesting here is that it like we'll talk sorry, go ahead.
Coming back.
Certainly. The payment is confirmed, and your updated balance is
Thanks a lot.
820.
Appreciate that. Bye-bye.
All right, we got there in the end. So this is super interesting, right? So I think like what I find really, really interesting, having worked on this my whole life, like we got used to turn taking, and I think people got used to turn taking. And what I've found frustrating, frankly, is that we'll all remember a very famous client who called me enraged, and we dealt with it for like a whole day when our engineering team cut the latency so much that it started interrupting people. And, I was told the system's not working. I called it, I was like, it's working better than ever.
Yeah.
And I think that was like where I realized that, like the target user is very different from people who work on voice AI day and night.
Right.
The way you interacted with the system right now, on the one hand, looks like a great interaction because you were so assertive.
Correct.
But I think the issue is you were that assertive. And I think
Because I know how it works.
Exactly.
Majority of the
yeah.
users, the coder don't know.
They don't, right? Like they wait, they're not confident about interrupting it. And most importantly, they expect it not to work at all, right? So based on that, I think like it's very interesting, and it will take a bit of time for the general population to start using it the way you did and beating it around.
Yeah.
Because like it worked. It could take at the end, I think maybe that comes to the heart of like the RAG and function calling, and I'll let you explain like the claims there, but that's like where I think the flip side downsides of S2S comes in. But
Yeah. So I think, this is actually an interesting behavior. Like now the initial orchestration, I think that we'll probably have to do a little bit more work there. But like, sometimes the agent does actually have an event that emitted, and then we probably not immediately processing it, or that event just happened a lot later, because now it's as I say, it's a single stream of audio. And then when the event got triggered, it becomes a little bit uncertain. So like it's sometimes, if the model is actually trained well, it should actually very properly reacted at any single point of time. So I think this is something that we'll have to look into a bit more. But I think overall, that orchestration is very powerful. Technically, in those kind of events, we just need to actually issue another event into the stream, and then we'll be able to get the response back. But I think because now we probably do like a more vanilla integration, so then therefore the behavior is actually really depends on the model. But yeah, I think that definitely solvable.
Oh no, totally. I mean, I think that but I think it is interesting. So people kind of go like, what are the drawbacks? What is it less good at? Why would we all not go like full speech to speech right now?
Correct.
And I think, we've definitely spent our lives trying to make things more data driven end to end than one model right?
Correct.
To learn these behaviors and everything. So like we are all for it, right? And we love that people with infinite resource who are able to work on this are working on it because we think it's an important problem, right? But like, what is the difference between like how RAG is done, like what actually is the difference like for someone implementing a voice agent?
Yeah. So basically, for voice agent now, for these like speech to speech agent, there's basically one single prompt, and then you can still trigger events like tool calls. And those tool calls you can feedback the tool call with the result back to the agent. So pretty much the orchestration is very similar to your traditional agentic applications. The only difference now is that the input of the user, the conversation between user and agent, become a one single stream of events. Mm-hmm. And those single stream of events, you are basically now, there are several orchestration differences you can do, because I think OpenAI is thinking about, different kind of use cases. It could be the telephone use cases we just showed. It could be also a push to talk, the kind of use case, very similar to with web chat, WeChat or Apple Siri, right? And then, so I think they allow you to do a lot of different kind of orchestrations. So you can actually say that now I wanted to behave like a teacher in the school, and I only ask a student to actually say something back when I allow them to. So that's actually what we are doing here. But then you can also say, hey, let's that student go crazy. They can put the project to us.
Serbian school experience.
Exactly.
I'm kidding. Sorry.
Yeah. But yeah, so this is like, it's basically a very powerful like orchestration framework they have built into the API and the system. So now you can build a lot of this. But then basically everything becomes an event. There's like a single process that executes all the time. The traditional RAG approach is that RAG is always run, and then you feed the content then later to the agent. Now it's the other way around. Agent always get the prompt first, and then agent decide whether I wanted to trigger a RAG or not.
That's actually really common sense if you think about it. Like when you ask me, like, is the sky blue? I don't Google, like, is the sky blue? And consider that before I respond, right?
Correct.
So really, you want me to just go like, yep, and you continue rather than like RAG, even if it's like 2 seconds, like it's 2 seconds where I should have just said yes.
Totally, yeah. So I think, by doing that, you give all these freedom and capability back to the agent. But then, if the agent is actually not good enough, not strong enough, the hallucination risk is higher, for sure.
Yeah.
Right? Because now you no longer do the filter of the contents on behalf of the agent. You say now it's your job. You do the filter yourself.
Yeah. I mean, also what is interesting, like in this world where like you push everything into a single prompt, it is easier in theory to start. Like always, it pushes the whole like impressive demos ever easier. And then controllability in terms of why did it do that?
Correct.
It's not like 4 rack topics are triggered and then you go into one of them, see that the piece of information is unclear and you change. You kind of go back to looking at it's as if you had the whole like code base in one file, right? And like, sure, the mistake is there. Yeah. The only problem is everything is there and you don't know how it's linked, how it works together, how like mutually contradicting information is.
Now, with this, maybe it's like this new release or actually previous ones. I think the entire orchestration tool, as I say, they have already perfected it. So previously it used to be like, there's only one simple prompt and then there's like not a lot of control you can do. Now you can actually use API to actually orchestrate these contexts and then, so allow you to do sophisticated context engineering with these voice agents already. Yeah. So we will have to see like how the attack effect of that would look like. But this is looking very promising.
No, it's powerful. It's really, really powerful. So okay, like we feel good. Like in terms of the voices they released, I think there's like Marin and Cedar.
Correct.
Right? Yeah. They're decent. I mean, I wouldn't say they're the best. Like there's voices.
I still have not found the British female voice yet.
She's great. Like I use that one in my like app. I guess we're like in the UK, but like it's I like that voice.
Correct.
Like she agrees a bit too much, and every first sentence is, "Oh yeah, that's exactly right. You got it." And I feel like it's a bit condescending. But other than that, like it's better than these two in my mind.
Yeah. Well, the only thing I think the voices available on the API is still predominantly US voices. We would love to see a bit more diverse of accents and different regions. And I think that's why like in our platform, even though we put speech to speech in a lot of use cases, we will actually turn off the output of the audio of speech and then leveraging a different better program.
I mean, okay, let's be honest. Like the value of like an end-to-end model, like if you unify understanding and the whole like reasoning and even like the generation in terms of like the text, like sure, if that thing is a streaming model and one model, you've got all the benefit already because then it streams to text to speech, it works. Maybe it has like a few tens of milliseconds. Yeah, that's actually
the only thing I haven't yet to try is whether Mrkšić would work in that text output. So if you turn off the speech to speech audio output and then just use their text output, I don't know whether the text actually recognize your name correctly.
I think that's something. I think that's fully down to like the pre-training of the text to speech engine. Yeah, like has it seen weird names like mine that like inferred? Like honestly, if you just look at the text representation, like the sh and ch are not encoded in the S and C that we spelled adequately, right? So like you'd have to almost like have. Yeah, it's cool that it has that. Like so the speech model I think is interesting, right? It would have heard the way we said it.
Correct.
Whereas but it said it really well.
Yeah,
it arguably better than you. Totally. Which means that it had pre-training. It inferred and it knew.
That's pretty good. Yeah.
It's the Serbian sh and ch, not the Polish ch or whatever, right? It's.
I can't really tell the difference there, so
I can bear. Oh yeah, it takes a lifetime of torture with Slavic languages. Yeah, but no, really fascinating stuff. It's again like okay, so it's natural, it's great. I think like a lot of voice platforms are all over it. I think that a lot of their orchestration will probably over time move towards orchestrating to this like no turn taking paradigm and like a different way of context engineering. What about the benchmarks? What are they saying in the performance?
So I think, together with this release, they released like 3 different benchmarks. To be honest, like each of the tasks actually has its own nuances. And then as a non-tech person, it's probably harder to actually interpret everything at all. I think I just make it super simple for everyone. So there are 3 different tasks. The first task you can consider it as a single turn understanding. Like, I give you a task in one go, and then you try to complete a task and then reply back to me. So that's single turn.
Single turn. It's not dialogue.
Yeah, exactly. Okay. Single turn accuracy. The second one is more.
And how are they doing in that one?
So we can go one by one. So in that single turn, they have a comparison to the previous benchmark, which was the first release of voice-to-voice model. The performance is around 66, comparing to the latest one, the recent release is 83. So it's a huge, big jump in terms of performance.
So from 66 to 83.
Correct.
And the ceiling being 90.
The ceiling being 90 is actually the cascaded pipeline.
Okay.
So if you think about cascaded pipeline with like, speech, their own GPT-4 transcribe plus LMs plus like a TTS, then the accuracy can up to like 90 plus.
But we all know that, like, in that one, I think the latency is like 6-7 seconds.
Yes.
Because Whisper is like a nuclear model.
Correct.
And they're waiting.
However, like you can make it faster, so cascaded latency could be a lot shorter. And then
Well, if they ran it through our platform, it'd be a lot
exactly.
faster.
Exactly. But I think that's kind of like the performance, like, you should be aware of. So around 7% is that accuracy of a single turn. When you are using speech-to-speech versus cascaded system. So like technically it's not bad, but then if you think about the conversation lasts for several turns, the performance will gradually degrading very quickly. So that's the second task that evaluate on, which is more of a dialogue level evaluation. So the task is like, hey, I wanted to do a trip, do a trip in Italy. Can you help me to plan it? And you have a several turn conversation. You say, oh, I want to add Rome. I want to add a restaurant. I really like it. I don't want it to go to the museum. So you have a lot of back and forth conversation, cap it to 10 turns. Yeah. And then in the end, you evaluate the performance, whether the agent actually factor in all your consideration into the final results. That's the evaluation. So in that evaluation, their performance this time is 30. Previous one was 20. So again, a huge improvement in terms of quality.
But still pretty low.
But then if you comparing to the SOTA model on the market, which I think is O3 or this reasoning-based model, it's about 63. And even with GPT-4 or GPT-5 without inferencing capability is around 50. So you can see that, okay, then it's
but arguably though, when you look at most like voice-based tasks that you encounter in our world,
correct.
Like this is way too skewed towards reasoning.
Correct. Yes. Yeah. This is still a very difficult task, but it kind of gives you a good gut feeling of how good the system is. Like where is the gap, right? So in terms of accuracy, reliability, the final one, it's basically purely on tool code reliability, right? So I think the GPT-4 or tool code accuracy was around 80. So that's like the benchmark you're comparing to. Their new speech-to-speech model is about 66 or 67. Yeah. The older generation was around 50. Again, big jump comparing to the previous one. But if you're comparing to the pure text-based models, the tool code reliability is actually there's still a little bit of Now, in our enterprise production use cases, even 4.0 sometimes is not reliable enough. That's why we have to train our in-house Raven model to actually make the tool code accuracy absolutely not a problem. So I think there's still a little bit of a way to go. But
I mean, I think that's the thing, right? OpenAI is serving to a very wide audience, right?
Correct. Yeah.
I think people building this are mostly building more social-oriented, like interesting applications, right? And I think for that, like, I mean, not to say that this isn't a problem, but like it's less of a problem. Right?
Correct. Yes. Yeah. So I think that's kind of like roughly how I would think about it. So I think in terms of naturalness, the entire user experience wise, like speech to speech model is definitely hands down the best. You can kind of get quite close with the cascaded system in terms of latency, in terms of the performance wise. Yeah. But when you're comparing reliability overall, like cascaded system is still not.
So okay, I think that like everyone's favorite question, like Sam Altman releases a new thing and kills the way of startups. Like who did this release kill?
I think if you think about it, right? Oh, one thing about this, to answer your question, there's also a very important feature comes with it, is that speech-to-speech model now also integrate with SIP and MCP protocol as well. So you can kind of, you think about it's like an integration to actually get to more users.
Yeah, so the SIP protocol, session-initiated protocol, is basically the main way of like systems integrating with telephony stacks these days in like the voice over IP over the internet world. So there, I think it's basically their attempt to, to answer my own question, but they're coming after the rappers who've kind of like made a life out of plugging in sufficiently interesting, like, DeepGram integration probably
Yeah,
on
yeah.
the front end, then OpenAI, then, text-to-speech, mostly 11 Labs.
Yeah.
I think partially DeepGram and 11 Labs are themselves like doing this stuff as well.
Yeah.
And with that, it's kind of like OpenAI just going kind of like moving the borders of their land for
Yeah.
one set of castle walls further out, right?
Correct. Although, though, I don't think that OpenAI is actually picking up on them.
No.
It's just like a natural evolution of their product strategy, require them to build up these new integrated question endpoints to get to more users.
Yeah.
So they're actually building up their product, but while you're building up their product, they are destroying a lot of purpose of the other companies as well.
Well, yeah, because I mean, if you can buy directly from the source and get
Correct.
I think those integrations, the telephony integrations, are really valuable, right? I mean, and SIP by itself still means that you have to do a lot of work to integrate. It's not a done deal, but it's a prerequisite, right?
Correct.
Yeah. And I think a lot of these other wrappers assume that this won't be available and worked with like Twilio plus PSTN, public switch telephony network, so like the kind of like simple telephony redirect.
Correct.
And assume that that's the best they're going to get. Now with SIP, this opens up the ability to implement directly I think this is actually serving a market of like deep, well-equipped builders inside enterprises that want to try out their own things.
Correct.
It still doesn't really give them a platform around the
Yeah.
voice agent for analyzing its performance, testing for these hallucinations and all of that. But it's definitely a step towards providing some of that.
Yeah, I think there are lots of product opportunities you can build around it. And to be honest, like having speech-to-speech models be more powerful natural conversation is actually great for the entire community overall.
Yeah.
This would just mean that this adoption of the technology will become much more like faster and clear. So I think for the community overall, it's very good. But then, if you are building a startup, you really need to think about where you have the niche and then what are the product features you build around it actually matters. Like the orchestration of getting down the latency, whatever. Yeah, that's great.
But you've logged for one.
But then, you no longer matters. And when the technology gets better.
I mean, when you think about this world, right, where like you have a lot of these like quasi-developer like companies that make it a bit easier for the developer to do more, right?
Yeah.
Like it's a dangerous land to be because everything around OpenAI, the first layer is an opportunity, but they may just come out and make it even easier, which they can do because of first-party integrations and like the fact that they own the model itself, right? So
correct. Yeah.
I think there you might experience fast growth because you're making it easier to access them with like a lower latency kind of thing to wrap around an LLM.
Yep.
But then when they release something like this, like you're kind of left with no USB and nothing unique you're offering.
Yeah.
Well, I think that kind of like squares out the topics we had in mind. Any final thoughts? What do you think happens next with all this from OpenAI, from everyone else?
I think it's very interesting. I think, we started to see these different model providers have different product strategies. Like LM, like for example, OpenAI goes a lot into real-time speech, and then they do a couple of like vertical industry applications like healthcare and education.
The demo, right?
Yeah, exactly.
Phenomenal.
And then they have another, like if you think about Anthropic, they are going on like heavy inferencing based tasks. And they do actually say that it's not in their strategy to actually ship real-time API like this, right? So they are looking at a lot of
like carving
coding,
the land slowly, right?
Coding use cases, whatever. Gemini is doing a lot of like multi-modal input. They don't do a lot of multi-modal output, like these real-time speech outputs, but they do a lot of input, like understanding videos and images and things like that.
And Grok is there just to offer a politically correct version of that.
Which is perfect because I do think there's a
yeah.
huge gap on the market there.
Yeah. Very cool. But I think like just in terms of these performance, and we rounded off a few numbers, we'll see if we can get them embedded. But like the saturation that we kind of saw with like GPT-5, right? Like there is a moment here where like with voice, this is like still a big push in terms of those benchmarks at least. And I think the subjective improvement is also strong. Where do we think the saturation starts kicking in?
Yeah, I think,
and on what parameter?
I think if you look at that, right, from the real-time voice speech API wise, in terms of the growth, the performance improvement of it, you can kind of imagine it will still continue to improve over time. And then all these like accuracy numbers, when they release the next version, definitely would be becoming a lot better as well. But the thing is that all these voice accurate, those are kind of like tool code accuracies and reasoning and understanding capabilities still it's going to be very similar to the text-based reasoning. But text-based reasoning is simpler to do because it's always like text in, text out. But now it's like audio. The audio model needs to first decide what's the boundary of a sentence, and then so that they can actually do reasoning on top of that. So you can imagine that's inherently going to be a much harder task to do. So I do think that it will follow, the performance improvement will follow very closely as the text reasoning models improvement curve. If we see, and the good thing is that text model is going to be always ahead of speech model anyway. So if we started to see text model as a sign of slowing down, then you can definitely expect the voice model will slow down.
So just for a lag of what a year.
And also, and then roughly around that. And if you compare the actual instruction following and all these reasoning capabilities, voice model is not only 1 year ahead, behind. It's actually more than that. The accuracy wise. And then if you think about it, text model has so many different companies competing for it. Voice is relatively, niche currently to the OpenAI because they are the main major company invested very heavily on that. So without the competition, I don't know how much they can actually push that boundary.
It's actually surprising how little. I mean, okay, forgetting like the other companies that have historically had large, like voice assistant, consumer voice assistant things. Like I'm surprised with how little we're seeing from Google these days. Because they've got the people, they've got the data, they could be in this arena. Very aggressively.
Google,
we await.
Google Assistant gets worse and worse every day.
Terrible. Yeah.
I don't know why. They lay off a lot of people. That department definitely is not doing well. So.
I've been watching my daughter trying to play APT on, Google Assistant. It worked 1 in 50 times.
It shouldn't.
Yeah, given that it's song probably played by like 1 in 30 people playing a song in Google Assistant, you'd think that
it should work.
You think that it would work? Yeah,
that's right.
Cool. Well, Shawn, thank you very much.
Thank you.
Everyone, thank you for tuning in. Like, share, subscribe, and let us know if there are any specific topics you'd like us to cover in the future.
All right.
See you then.